Okay, so we just did the BCR for this. Now we're going to do this second objective here, where we're going to learn the properties of trig functions in order to find angle measurements. So there's three main trig functions that we're going to learn today, and I've broken them into parts. And every time you're going to be finding some angle measurements, and I can actually put and side lengths in here because you're actually going to find some side lengths for some of the triangles at the last page. Okay, so we're going to start off with the easier theorems first, and then it's going to get a little bit harder as it goes. So our first theorem is the complements theorem. Theorem states for all theta, now this symbol means theta, it's like a circle with a line through it, it's simply just the angles. So it's kind of a little symbol that we use for the angle itself. So theta between 0 degrees and 90 degrees. So usually all these theorems, all the angles, or all the thetas have to be between 0 and 90. So the first part of it is that sine of theta equals cosine of 90 degrees minus theta. Now these thetas are exactly the same, so I'll make them in red because they're going to be the same number. They're not going to be different, it's going to be the same. So the next part is, because it's a two-part theorem, it's kind of just the opposite. If we had sine of theta, now we can have cosine of theta equals sine and then 90 degrees minus theta. Same thing with this one. These thetas are the same. And we can easily test it on our calculators because they will work out to be the same. If you do sine of a number and then cosine of 90 minus that number, they will be the same value. All right, let me show you one example, and then you probably should get it, and then you'll be able to do the other three. So I'm going to do this first one. It says if 0 is less than theta, which is less than 90 degrees, and cosine 65 degrees equals sine of theta to the nearest degree, what is the value of theta? So again, we need to figure out what theta is. Now, it doesn't just equal 65. Remember the theorem that we just stated. If I have sine of theta, I'm just putting my own unknown here on the left. That's my unknown. And it's going to equal cosine of 90 minus, now 65 is also my theta. So I'm going to put 65 over here. So all I really need to do is 90 minus 65. So that means my theta equals 25 degrees. And that's my final answer. Theta equals 25. So try 2, 3, and 4. Again, show the work that I've shown so that I can see that you're getting the steps down. This is simply just going to be one multiple choice question or gridded response on your test. So make sure you understand the property because it's an easy one to get right. Okay, our next theorem is the Pythagorean identity theorem. This one is actually even easier. So it says, for all theta between 0 degrees and 90. So again, we're working with 0 to 90 degrees, and theta is still your angle. Here's what it states. It's cosine of theta squared plus sine of theta squared equals 1. Now again, just like in the last theorem, these thetas are exactly the same number. Okay, nothing tricky going on, they're the same. And you can test a couple with the calculator. Actually, I would prefer if you tested it. Notice where the parentheses are and where the squared are. So you got to put parentheses. Technically on the calculator's parentheses should also be around the theta. All right, let's do one example. So again, I'll do this one. So it says, look at the equation. Sine of theta squared plus cosine of 48 or 44.8 squared equals 1. If 0 is less than theta, which is less than 90 degrees, what is the value of theta? This is an important part to have because we have to know that this theorem only works between this and this. So if it didn't work out, we would have to do something else. Now, again, if this is our theta, that means this is our theta. So our theta equals 44.8. Test in your calculator, see if it's true. And then do 2, 3, and 4. Okay, here is one of the most important parts of this whole unit now. Sometimes we are going to need to use our calculators. Sometimes we need to memorize stuff. So calculators give us approximation. We've kind of realized that when we get a little bit different numbers depending on when we round. Now this table you have to memorize. You're going to need to memorize it before the test. I'm probably going to be giving you a couple like pop quizzes, we'll say, on this because it is so important. There is a pattern to this table, and that might help you, might not. You might just want to memorize it. So the first things first, sine of 0 degrees is simply 0. I'll do all the sine first, and then I'll do cosine, and I'll show you how they are related. So the next one, sine of 30, is, well, let me jump back to sine of 0 degrees. That is technically the square root of 0 over 2, which is just 0. Now my next one, I instead do the square root of 1 over 2, which is simply, square root of 1 is just 1 over 2. So far I have 0, 1/2. And you can type this in the calculator, check. If you do sine of 30, you're going to get 0.5. The next one, notice the pattern here. I have the square root of 0, square root of 1. That's what this is, square root of 2 over 2. And that doesn't simplify any. That'll give you a decimal, so that is simply my answer. I'm just rewriting it so you can see the pattern over here on the left, or the right. Sine of 60, square root of 0, square root of 1, square root of 2, square root of 3 over 2. That also doesn't simplify, so square root of 3 over 2 is just your answer. So we got the 2. Next one, square root of 0, square root of 1, square root of 2, square root of 3. Guess what this is? Square root of 4 over 2. What is the square root of 4? Guess what? It's 2. And then 2 on the bottom. So 2 divided by 2 is, it's 1. So we have 0. We have 1/2. We have square root of 2 over 2. Square root of 3 over 2. And then 1. Cosine is the complete opposite. So instead of starting at 0, it starts at 1. And then it's square root of 3 over 2. Square root of 2 over 2. And then it's 1 over 2. And then it's 0. Notice how it's related. Sine of 0 degrees is 0. Cosine of 90 is 0. Now tan. Tan is kind of special. Tan is found by taking the sine divided by the cosine. One of those properties also. So for this one, if I do this, what is 0 divided by 1? It is just 0. My next one, what is 1/2? It's going to be hard for me to write up here. Divided by square root of 3 over 2. When you simplify all that out, which we've done in other units, it's just the square root of 3 over 3. My next one, what is the square root of 2 over 2 divided by the square root of 2 over 2? Square root of 2 over 2 divided by square root of 2 over 2. Actually, all that cancels out. This is 1. Next one, sine, which is square root of 3 over 3, or 3 over 2, over 1 over 2. When you simplify that out, you get the square root of 3. And the last one, it's 1 divided by 0, which you can't do, so it's undefined. So again, you will have to memorize these tables. I should be able to tell you or ask you, what's sine of 60? And you say square root of 3 over 2. That sort of thing. Okay? This table is going to be very important for you. And now we're actually going to use this table to answer some questions. So look at the next triangle. First triangle here. All right, again, all these triangles. Now this is a perfect example of a non-calculator problem. Because these are angles that you should know. If this is angle 60, let's label our O, A, and H. We have H, we have O, we have A. Now it wants us to find both V and U. So we'll just start with one of them first. I'm going to do V first. Do V over here, and then I'll do U over here. Okay, so if I start with B, that is A, and I only have a value for O. So if I only know O and A, guess what? I'm using tan. So it's tan of 60 equals O over A. So 5 square root of 3 over B. Now you guys already know how to do all this. You know how to solve for B. All you're doing is getting B by itself, just like our other problems. Times B on both sides, times B. So I have B tan of 60 equals 5 square root of 3. Divide by tan 60. Divide by tan 60. So I'm left with V equals 5 square root of 3. And now we can look back at our table. What is tan of 60? Oh, it's square root of 3. So now we can simplify this. The square root of 3's cancel out, so B is just 5. And then that's our final answer. So if you want, you can put a 5 here. All right, now we're going to go to the next one. We need to find U. So I know my O and I know my H. I could actually use this 5 if I wanted to, but I'll just use my O and H because that's what I was originally given. So if I have O and H, I use sine. So sine of 60 equals my O over my H, which is U. Trying to make my U's look like U's, so pay attention. So I have U sine of 60 equals 5 square root of 3. Divide by sine of 60. Divide by sine of 60. So U equals 5 square root of 3. Figure out what sine 60 is. Oh, it's right here, square root of 3 over 2. Now remember, when you are dividing and then you're also dividing fractions, it becomes U equals 5 square root of 3 over 1 times the reciprocal. That's 2 square root of 3. So 5 times 2 is 10 square root of 3 over square root of 3. So guess what U equals? 10. And there you go. I'm going to do another example with you, but feel free to come back to this one. Because this one is like the other two that you're going to have to do by yourself. Alright, here's the other one. Alright, so here's my angle I'm missing. I go over, this is my O, this is my H, and this is my A. Alright, I'll do X over here, and I'll do Y over here. So if I'm doing X first, that's O, and I have H, so that means it's going to be sine of 60 equals O over H, X over 4. Times 4 on both sides. So I have 4 sine 60 equals X. But what is sine 60? It's 4 times the square root of 3 over 2. So I'm left with 4 square root of 3 over 2 equals X. Guess what 4 divided by 2 is? It is 2 square root of 3. So there is your X. Notice the 4's and the 2's, because they're outside the radicals, you can reduce that. But the square root of 3 is just hanging out. Still square root of 3. Alright, my next one, I got to find Y. That's my A. So I have A and I have H. So that means I'm going to have cosine of 60 equals my A, which is Y, over my H, which is 4. Times 4 times 4. 4 times cosine of 60 equals Y. But what is cosine of 60? Again, don't use your calculator. It is half. What is 4 times half? 2. So there you go. Those are your two answers. So what you're going to do is you're going to try 1 and 2 by yourself. see if you can get answers for X and Y and A and B, and then I'll give you the homework and you can start the homework early.